Okay, number 2. Okay, so I think this is the very last video for this semester, I think. Okay, so like this is really concerned with a repeated eigenvalue case. Okay, so process is same. We're gonna find eigenvalue, then we're gonna find the corresponding eigenvector. Okay, then we can set up the like solution form. Then we can find. Okay, here we go. So let's start from eigenvalue. To find eigenvalue, we need a find the lambda, which satisfies determinant a minus lambda I equals, okay? So it is minus 2.5 minus lambda and 1.5 minus 1.5 and 0.5 minus lambda equal to 0 into the AD minus BC. Then, okay, but like for my convenience, let me use the fraction form instead, okay? It might be much easier for me, okay? Negative 5 over 2 minus lambda and 3 half, right? Am I doing right? And minus 3 half and 1 half minus lambda equals 0 and much more compared. And that is negative 5 over 2 minus lambda times 1 half minus lambda and plus 9 over 4 must equal 0, which is negative 5 over 4 and negative 1. And in order, lambda squared, 2 lambda, minus 5 over 4 plus 9 over 4, which is 4 over 4. That is 1. Okay? You see, this one is perfect square. And I can say your only one lambda eigenvalue lambda is equal to negative 1, which is repeated case. Okay, then like okay, now we're gonna try to find like corresponding eigenvalue, eigenvector with lambda equal to negative 1. Okay, then to find eigenvector, we have to set up a minus lambda I and vector v equals 0. Okay, which is negative 5 over 2 plus 1. We have 1 half plus 1, and v1, v2 must be equal to 0 vector, which is negative 3 half, 3 half, 3 half, 3 half, v1, v2 must be equal to 0 and 0. Then the conclusion is 3 over 2 v1 plus 3 over 2 v2 equals 0. And I can say your v1 must be equal to v2. Then your first vector is 1, 1. Is okay? So, like with this one, I can say your first solution vector, solution function is e to the minus t and 1 and 1. Okay? As we discussed about this one before, like we have only one solution vector, right? But like this is not enough. We need another one, which is independent with this one. Okay. So as we discussed about it, and we're gonna say like this way. And let me define new function, new equation, which is a minus lambda I, and we're gonna introduce new vector w must be equal to v. Okay. Which means negative 3 half, 3 half, because your lambda equal to negative, right? Negative 3 half, 3 we have. And let me say W1 and W2 equal to V, which is 1 and 1, okay? So I think I need more space. Give me 1 second. Here we go. So we are here, okay? So this calculation is really simple. Here we go. Minus 3 over 2 W1 plus 3 over 2 W2 must be equal to 1, right? So we can say if I multiply 2/3 on both sides, and it is minus W1. Okay, let me multiply negative 2/3. It might be much easier. W1 minus W2 is negative 2/3 now. Okay, so let me add W2 on both sides. Then I can say my W1 is W2 plus, no, minus 2/3. Is it clear? So if I say my W2 is equal to 0, then my W1 is negative 2/3, okay? So I can say my vector W is negative 2/3 and 0, okay? And that's it. We find W, then we can set up like second vector function, right? Here we go. Then I can say, did I use U or X? Okay, X. X2 will be set up like this way, is equal to t times e to the minus tw plus e to the minus t. Oh no, t times e to the minus t v and e to the minus t w, which is equal to t e to the minus t, and my v vector was 1 and 1, and e to the minus t, and negative 2/3 and 0. Is it clear so far? Okay, so let me simplify this guy. Okay, it is equal to t e to the minus t minus 2/3 e to the minus t and t e to the minus t. That's it, right? So that's it. Like we have like x1 and x2, and I'm pretty sure that like they are independent, which means x1 and x2 form the fundamental set of solution. Okay. Then now, okay, like there are two ways. Okay, as I introduced, like we can use the fundamental matrix, but it is a little bit complicated. Okay, but for this method, since it's 2x2 matrix only, we can just set up like linear combination, which is C1 times x1 and plus C2 times x2. Okay, so let's do that like this way, in short. Okay. Okay, so your xt will be equal to C1 times x1 plus C2 times x2. Let me use the, let me combine this guy, okay? Equal to C1, my x1 was, where was it? Oh, there we go. E to the minus t and e to the minus t, right? And C2 times x2, t e to the minus t minus 2/3 e to the minus t and t e to the minus t. And when you combine these two guys, C1 e to the minus t plus C2 t It's not necessary. Okay, let me plug in the initial value directly. Okay, here we go. So initial condition was given by, where is it? X0 equal to 3 and 1, 3 and negative 1, and plug in 0, then it would be like all the exponential part equal to 1, and like if they have t, it equals 0, right? Then it would be c1, and second part, the t e to the minus t equals 0, and minus 2/3 c2. And second part, we have only c1 must be equal to negative 1. And I can simply say c1 equal to negative 1. And since c1 is negative 1, your c2 must be equal to negative 1 and plus 4. To be the 4, it must be negative 6, right? So my conclusion is negative plus minus 6 t e to the minus t third minus t t e to the minus t. That's it. Okay. Again, if you set up the fundamental matrix and followed the way that I explained in the previous one, and definitely you can get the answer. Okay. But we don't have to do like that way. Okay. So we can just set up like a linear combination and find coefficient is fine. Okay.